along with the 90% or the 98% interval, depending on the size of the interval that we want to construct. But let's just work out these particular values here. So this becomes 0.7 minus z times some number here. What's that number? Well, it's the square root. In this case, it's the square root of 0.7 times, let's say, 1. Actually, let me maybe do this in stages. So what I'll do is I'll just do the numerator here first. So it's 0.7 times 1 minus 0.7, okay? The numerator here in the fraction is 0.21. So it's z times the square root of 0.21 over 600. So it's the square root of that, okay? Must be less than our population proportion, which must be less than 0.7 plus z times that same factor that we had over here, which is 0.21 divided by 600, and it's the square root of that, okay? So let's figure out what this factor is here, this square root of 0.21 divided by 600. So the square root of 0.21 divided by 600 gives us a value of 0.0187. So what we know now is that the true population proportion must be 0.7 minus z times this number, which is the same as, well, a times b is the same as b times a. So this number here, this square root, is 0.0187 to 4 decimal places. So it must be minus 0.0187z, must be less than the true population proportion, which must be less than 0.7 plus 0.0187 times z, okay? And that's the confidence interval, okay? So this confidence interval, this lower bound and this upper bound, is actually dictated by, okay, or is actually parameterized by this unknown coefficient or this unknown parameter here, which is z. So the only thing that's going to change here is this particular z value, okay, is what's going to change, okay, is what's going to determine the lower bound and the upper bound. Now the question is, how the hell do we figure out what this z is? Okay, well, to do that, what we need to do is we need to go to our z tables. Okay, so let's actually do that. Okay, so what we're going to do is we're going to go to our z tables. Okay, let's go to our z tables here. Okay, oops, did I knock that there? I did. Okay, let me just move that around here. Okay, so what we're going to do is we're going to have to calculate the z score that goes along with a 95% confidence interval. Actually, let me just get rid of some of these here because these are for another video, okay? Now the z's distribution is a symmetric distribution, so the z distribution is symmetric, okay? It's a symmetric distribution, okay? That's centered on 0. And what we'd like to do is we'd like to have an estimate of our true population proportion, okay? And it's a 95% confidence interval that we want. So what we need to do is we need to figure out what are these critical values, okay, that have the totality of the area in the tails is 5%, okay? We want to do a 95% confidence interval, so what we really require is we require that we have 95% of the area, okay? 95% of the area under the curve between these two critical values here. Let me call this C1 and let me call this over here C2. So if there's 95% of the area between these two critical values, well then that means the tails must account for 5% in total, okay? Which means that 0.025 must be in this tail and 0.025 must be in this right hand tail. Now the tables that we use here at the National College of Ireland are cumulative tables for a Z distribution. Okay, they're tables that give us the appropriate Z scores, okay, that have a certain amount of area to their left hand side. So their cumulative area is up to a particular Z score. Okay, so if we look at this and keep note of the symmetry in the curve, if we find this critical value over here, well then we get this critical value over here for free through the symmetry of the curve. So what we know is that 0.025 of the area needs to be on the right hand side of this critical value. So the area from here across needs to be 0.025, which means that the area from here across all the way down needs to be 1 minus this, which is 0.99750. So the area from this critical value here down, okay, this critical value C2 must be 0.9750. So the question is, can we find 0.9750, can we find that inside our Z tables? Okay, so what I'm looking for is 0.9750. Okay, what row is that on, and also what column is that under? Okay, once I have them two values, I add them together. Okay, and that gives me the appropriate Z score that has 0.975 of the area to the left hand side, which means that has 0.025 of the area to the right hand side. So let's see if we find that value inside our tables. So I'm looking for 0.9750. And actually here it is here, if you can see it here, it's on the row 1.90 and it's under the column 0.0, you can't really see that, 0.06. Here's the value right here. 0.9750 is on the row 1.990 and it's under the column 0.06. So what we know now is this, is when we add these two things together, we end up with the Z is equal to 1.96. In other words, this value right here, okay, this value right here, okay, is 1.96. Okay, which means that this value over here, okay, that this value here must be minus 1.96, if that makes sense. But either way, our Z score is 1.96. So now what we can do is we can actually calculate our confidence interval. Okay, so let's do that now. So our 95% confidence interval is going to be, so the 95% confidence interval